Hey, what's going on, guys? Let's do this problem right here. The question is asking 4.5 moles of an ideal gas is heated at constant pressure from 30 degrees Celsius to 150 degrees Celsius. Calculate the work performed by this gas. Draw a PV diagram for this process. So let's do the first part. So they are asking to calculate the work, and they have mentioned that this is a constant pressure. So if it's a constant pressure, we know this is an isobaric process, and therefore we can use W is equal to P delta V equation. But here, if you notice, we don't have the pressure or volume that is provided, so we had to find an alternative way to do this. Also, they have mentioned this is an ideal gas, right? So in ideal gas law, you know that PV is equal to nRT. So therefore, we can say that W is equal to nRT, right? N0 delta T. And here we have the mole, and R is a constant. We know that, and delta T is just the change in temperature. So we can calculate the work using these informations. So let's plug all the values. The moles is provided, that is 4.5 moles multiplied by this R, that's a constant. So here that value is 8.3145 joules per mole times Kelvin. And also, if you notice delta T, so here the temperature is given in degrees Celsius, but this we are dealing with the change in temperature, so we just have to subtract from final to initial. But when we subtract, if it's degrees Celsius or Kelvin, the change is going to be same. For example, even if you convert this one into Kelvin and subtract, you will get the same number, right? So whatever the value, change in value, that's going to be equal to degrees Celsius and Kelvin. So we can, if you subtract this one, what you get? 150 minus 30, that's going to be 120. So 120, we can directly put 120 Kelvin. So 120 Kelvin, and if you plug all this in calculator, you will get 4490. The answer is positive, because you know that as the heat increases, this one, what is this? This is yeah. So as the heat increases, the volume will increase. So if volume increase, it means expanding, right? Expanding means work done by the system. So we expect the positive answer. So we know that is positive. So positive answer. And then they are asking to draw a PV diagram for this process. So let's draw the PV diagram. So pressure volume diagram. So this is our pressure, and this is our volume. And initial pressure, we don't know what is that, but we know that pressure is constant. So pressure is not going to increase or decrease, is going to be constant. And then we know as the temperature increases, volume will increase. So we know we are going to have two different set of volume. So let's put V1, V2. As the temperature increases, volume will increase. So the PV diagram is going to be something like this, right? So let's consider this is initial volume, and this is the final volume. So this is at this point 30 degrees Celsius and 150 degrees Celsius, and that's how it goes. And that's all about it. I hope you guys like this video. See you next time.